So the first thing that we want to identify is where our surface low is located. And basically that's going to be at the center of the lowest pressure contour. So it would be somewhere right in here as analyzed on this map. Now, if you don't have time to do a full surface analysis, if you just are giving a quick glance to a surface map on the morning of a severe weather event, you can identify where a surface low is approximately located by looking for areas where the winds are spiraling counterclockwise around a given center. Winds spiral and rotate counterclockwise around a surface low. In our example here, we can see that is located somewhere there in the far southeast Nebraska, northeast Kansas, northwest Missouri corridor. Notice how the winds over much of eastern Nebraska are out of the north or north-northwest, turning to more westerly winds over eastern Kansas, more southerly flow over northwest Missouri, with more easterly and northeasterly flow over much of southwest Iowa. So at the center of that kind of spiral, that counterclockwise spiral in the winds is going to be where your surface low is located. Also located near the station with the lowest pressure, which would be this one here, 997.8 millibars. And of course, a full pressure analysis, isobar analysis, will give you the best chance of really pinpointing where that surface low is. But if you don't have time to do so, those are some good tips to help you find where that surface low is.
Don't learn storm chasing alone. Go where chasers are already talking. Discord community link in description.
In this example here, it's going to be located at the center of that lowest pressure contour there. So we would mark our surface low with a red L. Next, we're looking for fronts, cold fronts and warm fronts, and any other boundaries that are available at the surface. These boundaries are, again, very critical in the severe weather process because they can help initiate storms. We have our troughs that can help actually prime the environment for storm initiation, and then that forcing along these frontal zones where the winds actually come together, that can provide a little bit more focused forcing to actually initiate the storms themselves and set the severe weather event in motion. With a surface low, there is always going to be a cold front and a warm front. A cold front is usually always on the western or southwestern or south side of the actual surface low. And then the warm front is going to be on the eastern or northeast or southeast side of the surface low. So the cold front is always going to trail the warm front. So first, let's take a look at our cold front. Now, the way we want to find out the position and determine the position of frontal zones is through multiple factors. There are multiple ways that we can actually determine where a frontal zone goes. The first of these is through pressure tongues. When we do this isobar analysis, this pressure analysis at the surface, we can sometimes come up with these pressure tongues, these kind of tongues of the isobars here that kind of stick out, very much like a trough in the mid and upper levels of the atmosphere. It acts kind of like a ski jump. These pressure tongues are areas where the isobars kind of stick out a little bit like this. That is a classic sign of a frontal zone. We also have some evidence of a frontal zone through wind shifts.
Remember to check out those links in the description below, and then watch another video.